Welcome to sixth grade math. If you are out, when you return, you will have a quiz on operations as promised. And then we're going to go over homework. All right, today, mini lab. If you're following along at home, you can do this. Any number can be written as a product of prime factors. Number product is an answer for multiplication problem. Step one, fold a piece of paper in half and make one hole punch. Open the paper and count the number of holes. Record the results in the table below. So if you fold it once, there should be 2 holes when you open it up. Step 2, find the prime factorization of the number of holes and record the results. So if there are 2 holes, your prime factorization is 2. Step 3, fold another piece of paper in half twice, then make one hole punch. Complete the table for 2 folds. So if I fold it in half twice, it would be 4 holes, and the prime factors would be 2 times 2. Step 4, complete the table for 3, 4, and 5 folds. So if I fold it 3 times, I'll get 8 holes, and it would be 2 times 2 times 2. 4 folds, number of holes is 16, and it's 2 times 2 times 2 times 2. 5 folds would be 32 holes. 2 times 2 times 2 times 2 times 2 are the prime factors. So you don't have to take my word for it. Get out a hole punch and give it a try. Okay, mini lab continued. So there's our chart from the previous slide, our graph, and it shows us all the same information we had. There's nothing new there. So we can ask a few questions. So what prime factors did you record? 2's, right? All of the prime factors were 2's. How does the number of folds relate to the number of factors in the prime factorization? The number of folds is the same as the number of factors. So if we have 1 fold, we have 1 factor. 2 folds, 2 factors. 3 folds, 3 factors. 4 folds, 4 factors. 5 folds, 5 factors. Number 3, write the prime factorization of the number of holes made if you folded it 8 times. So if we folded it 8 times, 8 folds, 8 factors, 2 times 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 product of identical factors can be written using an exponent and a base. The base is a number used as a factor, so it's the bottom number. An exponent indicates how many times the base is used as a factor. So 2 times 2 times 2 times 2 times 2, so there's 1, 2, 3, 4, 5 2's. 5 factors. The base is 2, and the exponent's 5. So 2 to the 5th power is saying I'm going to multiply 2 times itself 5 times. When no exponent is given, it is understood to be 1. So 5 is understood to be 5 to the 1st power, but we don't write 1st power or an exponent of 1. Scaffolding questions. Prime factorization. We need to factor 125. So we have to ask ourselves, what can we divide 125 by? I say 25, and we know that 25 goes into 100 4 times, so it goes into 125 5 times. So 5 times 25. And now 5 is already prime, so we'll go 5 times 5 times 5 equals 5 to the 3rd power. Which number is the base? 5 or 3? It's 5. Which number is the exponent? Well, we've already used 5, so it has to be 3, right? 3 is the exponent. What is another way to say 5 to the third power? 5 cubed. Powers, numbers expressed using exponents, and numbers raised to the second or third power have special names. So 2 to the 5th is 2 to the 5th power. 3 with an exponent of 2 is called 3 to the second power, or 3 squared. And 10 with the exponent of 3, 10 to the third power, or 10 cubed. So whenever you're to the second power, you can call it squared, and to the third power, you can call it cubed. Examples: write powers and products. Number 1, write 3 times 3 times 3 times 3 using an exponent. The base is 3. Since the 3 is used as a factor 4 times, the exponent is 4. So we'll write it as a power. 3 times 3 times 3 times 3 equals 3 to the 4th power. Write 4 to the 5th as a product of the same factor, then find the value. Base is 4. The exponent is 5. So 4 is used as a factor 5 times. So we're going to write it as a product. So 4 to the 5th is the same as 4 times 4 times 4 times 4 times 4. Check your progress. Write each product using an exponent. So 7 times 7 times 7. Looks like there's 3 7s to me, so we're going to say 7 to the third power, or 7 cubed. B is 10 times 10 times 10 times 10 times 10. If we count those up, there's 1, 2, 3, 4, 5 10s. So we're going to write that as 10 to the 5th power. Write each power as a product of the same factor, then find the value. So if the exponent is 2 to the third power, we're going to write it as 2 times 2 times 2, and the value is 8. So 8 squared is going to be 8 times 8, which is 64. Real world example. Environment. In a recent year, about 10 to the 4th power youth across the United States participated in activities and events to care for Earth's environment. What is the number? So write as a product. 10 to the 4th is the same as 10 times 10 times 10 times 10. We're going to multiply 10 times itself 4 times. So now we're going to multiply, and we get 10,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So about 10,000 youths participated in these events. Check your progress. Coastline. Georgia has 10 square miles of coastline. 10 to the second power miles of coastline. What is the value of 10 squared? So that's that little spot right there where that red line just came up. So 10 times 10 equals 100. Tests. A multiple choice test has 7 questions. If each question has 4 choices, there are 4 to the 7th power ways the test can be answered. What is the value of 4 to the 7th? So how are we going to figure that out? We're going to multiply 4 times itself 7 times, and that's going to be 16,384 ways. And no, I can't do that very quickly in my head. So if you want to check the calculator, go ahead. Exponents can be used to write the prime factorization of a number. Remember to write the prime factors in ascending order, that is from least to greatest. So we want to write the factors from smallest to greatest. Examples: prime factorization of each number using exponents. When the prime factorization of each number, write the prime factorization of each number using exponents. So 72. So remember, we're looking for prime numbers. That is a number that has the only factors that it has is 1 in itself. And 1 and 0 are not prime. So we're looking for numbers other than 1 or 0 that only have factors of 1 in itself. So I like to start with a prime factor on one side of my prime factorizations. It just helps me keep things organized. You can do it any way you want, but every example I use will have a prime number on the left side of my factor tree. So I'm going to start with 2. That's my favorite. I know this is an even number, so I can do 2 times 36. And then I'll just bring the 2 down, and then the multiplication down. And then I will do 2 again, so that I have a prime number, 2 times 18. This is just an easy way for me to keep track of prime numbers. And I'll bring the 2's down, and then I'll go with 2 again. I know it's shocking, times 9. Then I'll bring the 2's down. 2's, and then I'll factor 9 as 3 times 3. So now I know that I have 2 times 2 times 2, so I can call that 2 cubed. And then I have 3 times 3, which is 3 squared. So if you notice, remember, we have to list the prime factors from least to greatest. So the other thing that this does for me, by starting with the lowest prime number I can, in this case it was 2, and continuing to do that through, is I don't have to rearrange anything after it's done, count up it's really easy for me to count the 2's from left to right and then the 3's. And as we go through, you'll see I do that on every problem. All right, so 135. So not a super easy one to figure out, right? But we're going to go with 3 because, again, I like to start with my lowest prime number on the left, and it's 3 times 45. Then I bring the 3 down, and I'm going to go with 3 again times 15, and I'll bring the 3's down, and I'm going to go with 3 again, so that I can keep them all in order, times 5. So those are my prime factors, and now I need to make them exponents. So I have 3 3's, so it's 3 to the 3rd power, or 3 cubed, times 1 5, so 3 cubed times 5. Number 6, 300. So I started with 2 again, because I'm looking for the lowest prime number I can, so 2 times 150. Bring the 2 down, times 2 times 75. I'll bring the 2's down. So I can't do a 2 now, right? But I can do a 3, which is the next lowest prime number, times 25. I'll bring down the 2's and the 3. And then I'm going to do 5 times 5. So now I have 2 squared times 3 times 5 squared. Check your progress. So we're going to factor 24. So once again, 2 times 12. I'll bring the 2 down, and then I'm going to factor 2 times 6. I'll bring the 2's down, and then 2 times 3. Those are my prime factors. So now I need to put exponents to them. So 2 cubed times 3. And then 45, 3 times 15. I'll bring the 3 down, times 3 times 5. All those numbers are prime. So 3 squared times 5. 120, 2 times 60. I'll bring the 2 down, 2 times 30. I'll bring those 2's down, and I'll do 2 times 15. I'll bring 3 2's down, and I'll do 3 times 5. So I have 2 cubed times 3 times 5. Additional examples. Write 5 times 5 times 5 times 5 using an exponent. So there are 1, 2, 3, 4 5s. So it's going to be 5 to the 4th. Write 8 cubed as a product of the same factor. So 8 cubed is 8 times 8 times 8. Now find the value. 512. Distance. The distance from Boston to Chicago is about 10 to the 3rd power miles, or 10 cubed miles. What is this number? So we have to multiply 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000. Write the prime factorization of each number using exponents. So 108, we're going to do 2 times 54. Bring the 2 down, 2 times 27. Bring the 2's down, 3 times 9. Bring the 2's and the 3 down, and we get 3 times 3. So now if we list these as exponents, we get 2 squared times 3 cubed. 80, 2 times 40. Bring the 2 down, 2 times 20. Bring the 2's down, 2 times 10. Bring the 2's down, get 2 times 5. And that's our prime factors. So we have 2 to the 4th, because there's 4 2's, times 5. And then 450, we're going to do 2 times 225. Bring the 2 down. And I can't do 2, so I'm going to do 3 times 75. Bring the 2 and 3 down. And I'm going to use another 3 times 25. I'll bring the 2 and the 3's down. Then I'll factor 25 as 5 times 5. So I have 1, 2. I have 2 3's, so it's 3 squared. And I have 2 5's, so it's 5 squared. Okay, here's your homework. Find the assignment in Google Classroom. And have a great night.